Atlas 767 Cpat review fuel system. Boeing 767 fuel system. Total fuel quantity 161,738 pounds. Left and right main tanks 40,669 pounds. Center tank 80,400 pounds. The left main system has two AC pumps and one DC pump, which is used for the APU. The right main system has two AC pumps. The center system has two AC pumps. In addition to the three tanks, there are surge tanks on the right and left wing. With less than 220 pounds in either main tank, the fuel config light and ICAS low fuel message will occur. The fuel config light will occur if the main fuel differs by 2,000 plus or minus 500 pounds in the right and left main tanks, or if the center fuel pump switches are off with greater than 1,200 pounds in the center tank. The surge tanks hold excess from overfill and expansion. All tanks are vented to the surge tanks, and the surge tanks flow back to the center tank. The tanks are fueled from a location on the left wing outboard of the engine. There are two AC pumps in each tank and one DC pump in the left main tank for APU starting with AC power off. The left main normally feeds the left engine and the right main normally feeds the right engine. There's a cross-feed manifold which allows feeding opposite engines. The fuel panel contains alternate action switches for pumps and cross-feed valves. With the main pump switches off, pressure light in the lower section illuminates. With center pump switches off, the lower switches are blank. At engine start, all pump switches are selected to on for the tanks that have fuel. The mechanical flow bar appears and the pressure light extinguishes when pressure is available. Note, if no AC power is available or there's no fuel in the tank, the pressure light will remain illuminated. The center tank pumps are selected on before start, but the pressure light remains illuminated to indicate that the pumps are not operating. The cross-feed switch remains blank until pushed on. When pushed on, the flow bar and momentary valve light will illuminate while the valve is in transit. The fuel quantity is measured by probes in each tank and corrected for fuel density. The total quantity is an indication of a separate calculation. The total quantity indicator and the FMC. FMC level is the sensed fuel quantity before start and accounts for APU burn. The calculated quantity is the originally sensed minus the fuel burn after start. Temperature is measured in the left main tank. A blank indication in a tank or totalizer indicates there is no power or a sensor failure. Each left or right main tank has two AC pumps, a forward and an aft. Each pump is capable of pressure for one engine. Normally, two pumps are used. There's a low pressure switch on each output. If no fuel is in the tank, or if the pump is selected off, the pressure light will illuminate. The center tank has two pumps, a left and a right. The respective center tank pumps are inhibited with N2 less than 50% on that engine. Both pumps are inhibited with engine shut down. Before start, the center pump are selected on with the pressure light illuminated, and the left and right center fuel pump messages indicated. The center tank pumps have greater output pressure, so the center tank should empty first if all pumps are on. The center fuel pump is inhibited below 50% N2, but that is removed when the fueling door is open to allow fuel to be pumped out of the center tank. With the center tank fuel pump switched on and the center tank fuel is depleted, center pump switch pressure lights illuminate and the center left and/or right fuel pump ICAS messages occur. With the switches off, the light and messages are inhibited for the center pumps. The DC pump in the left main tank is only for APU start with no AC power. The switching is totally automatic. If AC power is available at APU start, the left forward AC pump activates to provide fuel to the APU. The left forward AC pump switch does not need to be selected in order for this to occur. Each pump has a check valve to prevent fuel from being pumped back into the tank. There is a bypass check valve that allows engines to suck fuel out of the tank if no AC-driven pump is available. The center tank does not have a bypass valve. The crossfeed manifold allows any AC pump to provide fuel to either engine. Aircraft have one or two crossfeed valves. They are normally closed and are opened to feed opposite engines or to balance tanks. If the switch position and the valve position do not agree, the valve light in the switch illuminates and a fuel crossfeed, feed, or forward or fuel crossfeed message occurs. The fuel config light illuminates if left and right tanks differ by 2,000 plus or minus 500 pounds. If the center fuel pump switches are off with greater than 1,200 pounds in the center tank, or if the ICAS low fuel is displayed. Certain aircraft have a nitrogen generating system which provides nitrogen enriched air to the center tank when the bleed air is available to reduce flammability. This is automatic after takeoff and shuts down after landing and a short portion of the taxi. A small quantity of fuel will remain in the center tank at the low pressure light, and that fuel is scavenged to the main tanks when the main tanks are approximately half empty. Fuel jettison. Jettison is from the center tank only. The jettison nozzles are located just inside each outboard aileron. Be advised, it is possible to jettison fuel and still be over max landing weight. Two dual pump units provide force to jettison the fuel at approximately 2,600 pounds per minute. It takes approximately 30 minutes to empty a full center tank. To jettison, the switch is selected on, which opens transfer valves and turns on the pumps, and the nozzle switches are selected on to open valves. A fuel jettison nozzle ICAS message occurs if the switch and valve positions disagree or the nozzles are open on the ground. A fault light occurs if the jettison pump is in op, if switch position and valve disagree. Fueling and defueling. All three tanks pressure feed from the fueling station on the left wing approximately mid-span. Main tanks must be loaded equally within balance limits. If more fuel is required, the load is put in the center tank. The tanks can be filled in any sequence. When the fuel door is opened, ground handling bus provides DC power. The center fuel tank pump inhibit is removed. If any tank overfills, causing fuel to enter the surge tank, all fueling valves shut. Main tanks can be filled with overwing fuel ports as well. A defueling valve allows defueling the tanks using the tank fuel pumps or fuel pump suction. Note, fuel pump suction cannot defuel the center tank. That completes the review of the fuel system.